Hello, Geometry, Advanced Geometry. Today we're going to talk about special quadrilaterals and more definitions. These all are quadrilaterals. So as a proper definition, you need to state what it is, classify it, and then differentiate. But since they are all special quadrilaterals, we're going to just start them all as a quadrilateral. And then width. And then we'll differentiate it as we go in the box. So as you can see in the picture, what's special about a trapezoid is that we have one set of parallels. Okay, now it is exactly one pair of parallels, one pair of parallel lines. So these other two sides of the trapezoid cannot be parallel. So you have exactly one pair of parallel sides. Okay, and that's trapezoid. Kite. So kite is actually pretty difficult to describe. So it's a quadrilateral with, and you can see we have two congruencies here and then two congruencies here, but notice that they are not congruent to each other. So you can't have all four of them be congruent to each other. So to write that out, we're going to say with 2, and then I'm going to leave a little blank here to fill in a second, but 2 pairs of consecutive. So that word consecutive means one right after the other. Consecutive congruent sides. Now, if I just left it like this, that would not account for having all four of them be congruent to each other. And if you have all four congruent, that is not a kite. That's something else. So what we say here is you have two, and we use the word distinct. So that accounts for the fact that you can't have all the four be the same length. You have two distinct pair of congruent consecutive, so one right after the other, congruent consecutive sides. Okay, next, parallelogram. So this is a quadrilateral with two pairs of parallel sides. Now, what is unique about a parallelogram in particular is that it does have its own symbol. So, and this is the only quadrilateral that has a symbol, but you are going to use that to represent parallelogram. So if you were looking at this picture and you see that you have two sets of opposite sides that are parallel, notice that we have two arrows, and two arrows just distinguishes those parallels from the other parallels. But you can also say, instead of writing the word parallelogram, you can say the parallelogram symbol, P-A-R-L. So those would be equivalent to just writing the word out. No other quadrilateral has a symbol or notation. So if I see any sort of quadrilateral drawn, I'm assuming you mean parallelogram, because obviously this doesn't look so good, but any sort of quadrilateral drawn in a symbol form like that is a parallelogram in our book. Okay, next one, rhombus. So a quadrilateral with 4 congruent sides. And that's easy enough to see here in the picture. That one's pretty straightforward. Rectangle. So the actual definition is that it's a quadrilateral with 4 right angles. Okay, and then as you can see in the picture, you have your right angles marked. Now, you know this probably from like 5th grade or whatever, that the opposite sides of a rectangle are congruent to each other. But remember, we're just doing the definition right now. So by definition, all we can mark in this picture are those right angles. So by definition, we would only mark the right angles. and that is the least amount of information we need to know it is a rectangle. Square. So a quadrilateral with, and this is a combination of a rhombus and a rectangle. So we have to say both things. We actually did this in our definition notes, but we have 4 congruent sides, as you can see marked in the picture, and 4 right angles. So you need to have both things known to have a square. And like I said, you can't draw a square and write SQUA and think that that's a square. Okay, there is no symbol for square. You either have to have it marked in the picture or write the word square. Okay, one other thing we're going to do though is talk about how could we define square with just 2 words. So we're going to review over some of our old vocabulary for that. So we actually drew this in previous notes as an example for something. So pause for a second to see if you can remember. Okay, so what exactly did we use this as an example of? We used it for an example of a regular polygon. But in this particular case, it's a regular quadrilateral. So that would be one way that you could describe a square using just 2 words. There are many other instances on how you can do that. One other one, you can even look up here at the rectangle. You could say equilateral rectangle. That would be another way to describe a square using just 2 words. Okay, examples. So on number 1 here, I want you to pause and try to draw, label, and mark what is given. Okay, good. Welcome back. So you have a rhombus. So we're going to draw ourselves a rhombus. But I don't know it's a rhombus until I mark everything. So by definition, a rhombus has 4 congruent sides. Okay, and then I can label A, B, C, D. Remember, when you're labeling, you want to move around the shape with the letters. Okay, so this would be drawn, marked, labeled. Now we're going to do a perimeter of 8z plus 12. Well, knowing that these are 4 congruent sides, then I would know that each side would be equal to 8z plus 12 divided by 4. Now, you can basically distribute with division as well. So I'm going to divide into both of those parts. So 8z divided by 4 is 2z, and then 12 divided by 4 is 3. So you would label all the way around 2z plus 3, 2z plus 3, 2z plus 3, and 2z plus 3. Technically, you probably could get away with just labeling one of them with the congruency marks. It would be assumed those are all 2z plus 3. Number 2, try this one on your own. Pause and try it. Okay, good. Welcome back. So we're doing a kite this time. So let's draw the kite and then mark the kite. So we know those are congruent and these would have to be congruent but different than the original pair. And then we're going to do W, X, Y, and Z. There's nothing in the rest of this information that says I have to put the W in any particular place. So I'll just put it here. So W, X, Y, and Z. And then diagonals, remember, connect non-consecutive vertices. So I would connect WY and then XZ, and they intersect at P. So that would be the correct drawing with labeling and marking. Okay, last one. Again, take a minute, pause, try it yourself. Okay, rectangle. So we're going to draw the rectangle. And again, for right now, by definition, all we know is they have it's a quadrilateral with 4 right angles. So this would be the correct marking on the diagram. And then you have our E, C, and T. Okay, and then what you're given here is EC angle, the measure of angle ECT, ECT here would have to be equal to 90 degrees as a right angle. So then I can set up my equation, x squared plus x is equal to 90. And then solving that, so factor pairs that multiply to 90 but add up to a positive 1. Combine like terms to a positive 1. So 10 and 9 should work. I need a positive 1, so more positives than negatives. And then set each equal to 0 to find negative 10 and 9. Okay, it says solve for x. The one thing you do want to double check though is to make sure that they both will equal positive 90. You can just double check that. But here we get 100 minus 10, that works. And then 81 plus 9, that also works. So these would be my two x values. Okay, we'll see you next time.